Good day, all. I'm Carol Platts, VP of Marketing at Lightbits Labs. If you have an interest in application modernization, reducing storage operations cost, successfully running demanding workloads on virtual machines, then you're in the right place at the right time. Thanks for joining myself and two distinguished experts in virtualization and storage technologies. Sagi Volkov is a performance architect here at Lightbits Labs, and Joe Giordano, the Chief Principal Architect at Red Hat. For our webinar today is on how to eliminate storage bottlenecks to keep your VMs running smoothly, even during live migrations. And in my opinion, today's webinar is very timely. I think we would all agree, we were just at the Red Hat Summit a few weeks ago, and it was clear in speaking with some attendees there that storage for OpenShift is often underestimated or even under-considered. Yet it has a direct impact on workload performance, scalability, and reliability. In fact, one of the biggest challenges in virtualization is maintaining high-performance storage while enabling live migrations. So behind the scenes, Joe and Sagi have been collaborating and testing Lightbits high-performance block storage in OpenShift. And in today's webinar, they're going to walk you through their testing and explain the significance of the results. However, before I hand the mic over to them, while this webinar affords you great live access to experts like Joe and Sagi, all of the participants are muted during the presentation. And as such, if you have a question, please use the Submit a Question panel to ask it, and we'll see it there. Also, in the attachments and links panel, I've put links to both Joe and Sagi's LinkedIn profiles if you'd like to connect with them, as well as a link to the blog that they recently published on this same topic that lives on the Red Hat website. Okay, and with that, Sagi and Joe, the mic is yours.
Great, thank you so much, Carol. So I'm going to start off today, and then I will pass it off to Sagi to get more into the storage architecture. I'm going to give you a brief overview of OpenShift Virtualization. Some of you may or may not be familiar with it, and then we can get into live Q&A. So OpenShift Virtualization. Many of you have known Red Hat for our Enterprise Linux product, Red Hat Enterprise Linux, but we've been involved in virtualization for quite some time. So to understand our history with OpenShift Virtualization, we need to go back to 2007 when KVM became the de facto hypervisor for the Linux kernel. In 2008, Red Hat purchased a company called Kubernetes. Kubernetes gave us the ability to manage KVM hypervisors in a distributed fashion. We released a product called Red Hat Enterprise Virtualization, based on that acquisition. Our virtualization experience grew, and in 2012, we joined the OpenStack Foundation, and we released an OpenStack product called Red Hat OpenStack. Red Hat OpenStack has been available for quite some time and is still heavily utilized in specific environments like telco and FSI. In 2020, we saw a lot of our customers were engaging with our OpenShift product in ways that it made sense to bring virtualization into OpenShift. So we had our first GA release, general availability of Red Hat OpenShift Virtualization based on the KubeVirt project. So from start to finish, we've had virtualization experience that spans about 17 years. Now with OpenShift Virtualization, we're utilizing the APIs, the orchestration, the Kubernetes constructs, and the ecosystem around Kubernetes to orchestrate and control and lifecycle virtual machines in a very modern way. In the data center, we can do it, across different data centers, but we also are able to do that across the cloud as well as edge environments. So we've taken the 17 years of experience that we have with virtualization and KVM. We've applied them to OpenShift Virtualization to give our customers and the market a really robust alternative to other platforms that have left customers exposed to a lot of risk and liabilities. So OpenShift Virtualization provides the same virtualization experience that customers have grown to expect in a virtualization platform. So things like live migrations, storage migrations, cloning snapshots, and so many more. It supports business-critical capabilities that you'd expect from a mature platform, and it provides the ability to run virtual machines and containers side by side using the same control panel, control plane, and mechanisms that you choose. Some customers choose to separate these control planes, right, and have a separate virtualization environment and platform and a container platform, and that may be for regulatory or it may be for expertise reasons. And that's a perfectly acceptable use case, and it still provides a lot of the benefits that we see of a consistent management experience, as well as reducing the overall cognitive load of having disparate platforms manage both containers and virtual machines. So the open source community is very important to Red Hat. All of our work is done in an upstream fashion. And the open source community and the ecosystem around the KubeVirt project were very important to us when we decided to incorporate virtualization into OpenShift. Currently, there's over 133 companies that contribute to the KubeVirt project, and it makes it a top 10 CNCF project, right? So from a engagement perspective, it's a well-respected, well-contributed to project that allows our customers to really diversify their risk and make sure that the platform that they choose is supported by a multitude of organizations. Red Hat also supports multiple operating systems on the platforms, the Windows, the Linux, obviously. We provide different levels of subscriptions so that you can use the capabilities of the platform that you choose and the tooling that allows you to automate the platform from end to end. So you can have from day 0 to day 2 life cycling of the entire platform in an automated way. And we provide training capabilities and services capabilities to help really get your implementations implemented and reduce the time to value of this migration. Now, generally, we see 3 personas of customers that we talk to with regards to virtualization. The first being the brownfield customers that are looking for an exit strategy or diversifying their vendor strategy around virtualization. These customers generally look at their virtualization environment and want to move directly into another virtualization environment. Some of these are even completely net new customers to Red Hat. They've never utilized Red Hat Enterprise Linux, and they're coming to us for the first time. And they're really looking to eliminate the risk and the unforeseen costs that they're experiencing. And then we have customers that are skilled with Kubernetes and containers. Maybe they're OpenShift customers, and they see the value of modernizing and eliminating their traditional virtualization platform and the value of the Kubernetes orchestration layer. And they want to manage the platform. They want to manage both workloads side by side, so containers as well as virtual machines. And they want to reduce complexity in their environment. They want to rationalize their tool sets, and they want to reduce cognitive load. And then the last persona of customers we see are the customers that want to modernize their VMs, but their virtual machines, maybe not ready to be fully containerized, but they want to take advantage of some of the capabilities and the constructs of Kubernetes. So we call this like a stepping stone to containerization and modernization, right? They'll move a few VMs into that. So we talked a little bit about OpenShift virtualization and briefly covered what it is, right? We're going to talk a little bit about storage now and really dig into storage a little bit more so that when I give it over to Sagi and he explains what we've done with Lightbits, you have a little bit more of an understanding. A lot of these topics, obviously, we can go into significant detail, and so you can reach out to us after the webinar to talk a little bit more about it in specific details. But I want to make a couple of things understood and clear so that it all makes sense. One of the big differences between running containers and OpenShift and running virtual machines in OpenShift is that not every container needs storage or will get storage. But by contrast, every virtual machine needs storage, at least one disk for the operating system. By default, OpenShift uses the concept of persistent volumes, and this is a Kubernetes concept. Persistent volumes are managed by CSI drivers, container storage interface drivers, and they're the bridge between Kubernetes and the external backend storage. And they provide the capabilities of provisioning storage, attaching it, mounting persistent volumes for virtual machines to use and for hosts to have. Controlling the persistent volumes can be done automatically in OpenShift or manually. And this is really the desire of the administrator or driven by organizational requirements. But the mechanisms are in place to deploy fully automated end-to-end, including the storage, without manual interventions. storage has to be multi-writable, multi-node writable, which is read-write many in the Kubernetes world, in order to take advantage of capabilities like live migration. And this is generally defined by, the backend storage CSI driver to designate that, and the capabilities of the backend storage. Traditional virtualization uses the VirtIO and SCSI drivers. So those have existed since their inclusion in Rev. And they're also the drivers that the virtual machines will use to interact with the storage that's been provided to them. So storage can be provided or can be given to a cluster in two modes: file system mode or block mode. File system mode is generally NFS, or a layered clustered file system on top of storage, and block is obviously direct access to the block devices. In the case of performance, block is generally preferred, and partners like Lightbits have done a great job and will provision those block devices for you and present them as read-write-many. And it makes it a natural synergy between OpenShift Virtualization and Lightbits high-performance NVMe over TCP storage. The CSI driver is going to provide many of the standard capabilities that customers expect, and the interactions with the disks, since different storage vendors optimize their storage in different ways. So the CSI driver is going to give the permissions or the capabilities so that you can take advantage of your storage vendors' optimizations on their storage. So I hope this gives you a quick overview of the storage concepts around OpenShift Virtualization. I'm going to pass it off to Sagi for a little bit deeper dive into Lightbits and provide, he'll provide an explanation of how it really provides a high performance storage for your resilient virtual machines.
All right. Thank you, Joe. Let's talk a little bit about Lightbits. So you guys get to know Lightbits and the storage that we provide. There's really three pillars that we're focusing on. NVMe over TCP is basically a technology that, or a transport layer that we invented a few years ago, gave it basically to the network and Linux community. It is now part of the Linux kernel for a few good years on any enterprise Linux. And of course, on Red Hat Enterprise Linux, you get the NVMe TCP kernel model as part of the operating system. You don't need to install anything specific to use it. The idea behind NVMe over TCP, it's an extension of NVMe over Fabric. The idea is to use TCP, which TCP quick equipment or switches always exist anywhere in your data center or in the cloud, and use this overlay system basically to communicate with NVMe devices. Nowadays, NVMe over TCP is actually a technology that is being used by other storage vendors, though Lightbits as a storage subsystem was written from the ground up to utilize NVMe over TCP, and we'll touch a little bit about this later on. The second pillar is our intelligent flash management, which basically means we utilize and make sure that flash devices, SSD, NVMe SSDs that are being used in the Lightbits cluster are being utilized to the max. How do we do it? We aggregate and write in a very efficient manner into these devices. Basically, we enhance the life cycle of these devices, reduce garbage collection, and it's a very important point for our customers that they know that they can utilize more those devices for a longer time and in a much more efficient way. Lightbits provide, of course, all kinds of protection layer at the node level or the server level. We have our own erasure coding. So you lost an SSD device, which happens. Everything continues to operate at the same manner on that server. You replace the SSD device, it just automatically gets locked into our cluster and start to being used. Everything in Lightbits is thin provisioned, though we do offer a thick clones for some of the needs of our customers. We do provide a compression and, of course, snapshot capabilities. In terms of clustering, the third pillar, we basically cluster several servers into one logical representation of all the storage capacity. Adding new servers automatically gets being used in the cluster. If you have a server that you lost or a network issue to that server, something like that. We have replications of the data. One of the unique things with Lightbits is that you can actually choose the number of replicas or copies of the volume that you're creating. So it's between 1 and 3 copies. And it actually gives a very good benefit for our customers. They can basically choose whether they want to have the most copies, the most resiliency versus some pieces of data chunks that maybe do not even require protection. And again, even with a single replica, you still have a server erasure coding at the level to protect you. This is a kind of a very high-level architecture diagram. Not going to go, of course, through all of it, but basically at the software level, Lightbits is just a bunch of RPMs that are being installed on a Linux server. The front end is where we handle all the traffic that is coming from the clients, and where we also handle all the traffic that is going for applications and other things between servers in our cluster. This is, of course, all based on NVMe over TCP. This is also the location in the software where we aggregate the writes, where we handle QoS. You can choose basically volumes to be managed by, to be controlled by the bandwidth that you can provide for them. Lightbits was basically written from the get-go to handle multi-tenancy. And this is a part of this technology. Let our customers basically use Lightbits as the block building block for a cloud environment, and provide different bandwidth or QoS capabilities to their customers. We do software encryption and rest at that piece of information, and of course authentication when we have some sort of a rebuild between the servers. The front end handle that. Down below is our backend. This is where the Flash Intelligent piece of software is being done. This is us knowing how to write efficiently into the SSD devices. Also, of course, make it a lot more efficient to read from them. This is where we're handling the erasure coding, and identifying whether there's any issues with the NVMe SSD devices, where we're doing snapshots and clone. As I mentioned, everything is thin provision. We do have our own API services running on the clusters, which customers can integrate into, retrieve information, metrics about performance, about capacity use, all kinds of things, all sorts of monitoring that we provide, and of course, all of this is done on a software basis. So whether you run it on a vendor A, B, or C of servers, for us, it is just a hardware that we are running on top. Gives you the flexibility to choose which one you want to use. Let's talk a little bit about the NVMe over TCP. In a nutshell, this architecture basically provide a client, in our case, an OpenShift worker node or many worker nodes to access a volume which resides remotely on NVMe devices. From the operating system perspective, in this case, Core OS, all that is being seen is a regular NVMe device. If you and the demo will actually show this. If you look into the operating system itself, you're going to see a /dev NVMe something that shows up. That is the volume that is provided by Lightbits. So any interaction with that volume is done regularly as if it is an NVMe devices. And of course, the IOs then are being transferred through the TCP layer and the Linux network subsystem, and then remotely into the Lightbits cluster. One of the key benefits that NVMe over TCP provide is the ability to use to run multi-queues, basically to spread your IO interactions with the Lightbits cluster across as many cores that exist on the physical server. So by default, a queue is being created per core. You can, however, the NVMe over TCP spec allows you to control it if you really need to. But basically, that means that all the interactions that are being done from the client, in this case, again, Kubernetes or OpenShift, is being spread across across all cores and being sent into multiple, into wherever the volume resides on the Lightbits cluster. Of course, writes are being replicated, as I said, internally into the Lightbits cluster. Once all X copies, 2 or 3, in the case that you are doing replication, have been written, we basically acknowledge back that everything is safe on the devices. Because this is all over TCP, you can utilize any of the technologies that you are using now for resiliency at the network level, all sorts of bonding that you're currently using. Everything will continue to work as is. Little bit about where we roam, or where what can use us, and what our customers are using. So in terms of the what, pretty much anything that you think that can run on a block storage, and even more, runs. We get customers that are using those. A lot of all sorts of databases, whether SQL or NoSQL based. We even have customers that are sometimes running NFS on top of Lightbits volumes. That's really up to them. In terms of the infrastructure, you can see that, the Kubernetes domain, we have CSI drivers, OpenStack, we have Cinder. We do have also NVMe over TCP drivers for VMware. In terms of the where, as I mentioned, on-prem, choose the vendor that you want to run the hardware on. We do provide offering for AWS and Azure in the marketplace. And again, we are software defined, so even on a different cloud provider, you can still run Lightbits. All you need is NVMe over TCP and direct attach NVMe devices. So that's kind of a general view of where we run. So a little bit of more of high level features. It's a slide with a lot of information, so it's probably easier to read it after that. But I just want to make sure, going back, you can choose the number of replication that you're using. You have a ratio coding at the level of a server. Everything is thin provision. Snapshots are being provided. You can easily use them. You can increase the Lightbits, easily increase the Lightbits cluster by adding either more servers into the cluster. You can also scale up by just adding more SSDs into into each of the servers that are running the Lightbits cluster. Let's talk a little bit about the performance. So these are some informative numbers of performance. These are basically 3 servers that are running Lightbits, and there's about 20 clients that are using the Lightbits cluster. This is all using FIO, but the numbers I want you to keep in mind in here. And these are even a little bit outdated numbers that are even higher today with the newer CPUs from Intel and AMD. 3 servers of Lightbits. As you can see, 4K read-only, we're talking about 14 million IOPS. These are massive numbers. And you can see also the bandwidth that they can provide. You can also see the very low latency that we can provide. In this example, almost 4 million reads of 4K. And this is, again, going back to the benefits of NVMe over TCP, the multi-queue mechanism that it is using, not only at the client level, but also at the target level, at the servers that are running Lightbits. The idea behind having such a massive amount of abilities in terms of IOPS, the way that I look at it, there are applications that really can come and take advantage of these very fast IOPS numbers. But in most cases, what we are seeing is that customers look at Lightbits as kind of a chest box or a treasure box of unlimited IOPS. They get a Kubernetes cluster, in a lot of cases, many Kubernetes clusters attached into a single Lightbits cluster, and it provides all the abilities in terms of the throughput and IOPS that these OpenShift clusters can consume. When they are required to have more, they just start to add more of the Lightbits servers into the Lightbits cluster, or they can also start to add a more Lightbits cluster. And we're working now on a mechanism and a feature that you will be able to look at many Lightbits cluster basically as one giant aggregate a storage entity. These are some numbers that I ran on my test cluster using EDB's CNPG, which is an awesome project how to run and replicate Postgres on Kubernetes. In this case, I ran it on OpenShift. This is actually the same physical servers that I use for the demo that I'm about to show, and it's unfortunately it's my test cluster, so it's pretty outdated. But still, what we're showing here is a bunch of clusters that are running on OpenShift of Postgres. And when it says one cluster, it basically means a clustered Postgres environment, which means you have basically a standby and an active Postgres cluster running somewhere in the cluster. And you can see how the transactions that each cluster is doing is basically consistently increasing as we add more of these Postgres clusters and are able to basically utilize the Lightbits clusters. This is, 900,000 transactions per second. It is not something that you see any day. And the only reason is that I didn't continue this graph is because I only had 2 nodes of worker nodes of OpenShift, and that was basically the limit. The limit came from the servers that are running the worker nodes, not from the Lightbits cluster. These are some comparisons that we've done a few times because we do sometimes augment Ceph clusters with our customers, or sometimes we compete versus. Ceph is an awesome technology. I've worked with Ceph in my time when I was a Red Hat employee. Lightbits is just a much more modern approach on how to handle software-defined storage. And these numbers, you can see basically the gap and the differences between them. So let me try and show this video here. As you can see, the pretty outdated video. I'm going to share my screen. It's something recorded. Just give me 1 second. And hopefully this will work. And share screen. Here we go. And hopefully you guys can see me and hear me. It's more important you see the screen. So what's running in here is basically there's 4 windows in here that are running, connecting into a Lightbits cluster. I'm going to show basically a demo of a virtual machine migrating while I'm running FIO numbers on it. What I'm showing in here basically is the worker node where the VM, which is a Fedora based, is currently running. There are 3 Lightbits, the 4 Lightbits volume in here. 3 are basically used by the virtual machine. And as I mentioned earlier, this is how it looks basically from the operating perspective, as just as /dev NVMe devices. Right now, there are 3 volumes running to that VM, 1 for the operating system, and 2 where I'm going to basically run IOs on them. This is kind of to simulate, a real workload of, let's say, a database running on the virtual machine. This on the top left, what you can see is the virtual machine itself and how the devices are being looked over there. You can see VDC and VDD are the 50 gig devices. On the right side, we're basically showing IO stat of the 2 worker nodes that I'm going to migrate the VM while running FIO through. So on the bottom right, you can see that IOs are starting to be run on worker 3. This is where the VM is currently running. And I have started to run FIO on the VM. I've screened the VM in order for me to get back to it. I didn't have another network device on this cluster, so I couldn't use Maltos basically to consistently stream the output of the FIO. But you're going to see that while the VM is running, I'm basically sending the FIO output into this client that is running everything in order to capture this. And so the bottom right is IO stat on the worker node that is currently running the VM, and the bottom and the top right is where it's going to migrate to. On the bottom left, I've just started the migration, and what you can see is now OpenShift is saying, okay, where am I migrating to? I'm migrating into worker number 2. You can see now that the NVMe devices that the VM is using is already showing up on worker number 2. They are not being utilized yet. This is one of our unique capabilities with a CSI driver that supports RWX at the block level. And now you can see on the bottom left, basically, the virtual machine is already migrated. OpenShift market has succeeded. We can see that the IOs are now flowing into worker 2. And you just saw that on worker 3 on the bottom right, the NVMe devices, the Lightbits NVMe devices that were used are basically gone. I'm basically going to SSH again into the virtual machine, which now resides on a different location. I'm going to screen back into that. And you can see that the FIO, it continues to run with the same ratio and the same rate as before. That's basically a very, very short demo of us doing a live migration. If you look in our YouTube channel, you're going to see a new demo that I'm going to show up with actually running Oracle and Slob performance numbers while doing live migration of the virtual machines. That's basically it for the demo. Let's see now if we have any questions.
Yeah, we have a few. Thank you, Sagi, for that. I guess this is for you, Sagi. It's a technical question regarding the NVMe over TCP that you mentioned, but can you elaborate, and I think you did, I think you had a slide on this, on the specific technical architecture of Lightbits that it's able to achieve this high performance, particularly for latency sensitive workloads. I think your slide on the intelligent flash management and clustering kind of addressed this a little bit.
Yeah, so again, you have to look at it from let's call it the two opposites of of your environment. You have NVMe over TCP as a kernel model that utilize multi-cores environment at the client level. So in our case, OpenShift. And what that means is that you either have an application that can really utilize storage systems that can provide very high IOPS numbers, or which is a lot more common in OpenShift environments, is where you have a lot of pods, a lot of your applications running between the pods, the virtual machines, on the same cluster, on the same worker node, and they are all sending and receiving IOs, and they can take advantage of the multi-queue capabilities of NVMe over TCP. On the target side, again, the NVMe over TCP multi-queue capabilities help us consume, let's call it quote unquote, all the IOs that are being sent from the OpenShift worker nodes. And then the intelligent flash management is where we basically write things very efficiently. So when you read them, or in the case of writes, when you write them, the performance is just a lot more higher. And hopefully that answered the question.
I think so. There's a related question. I'm going to skip one question because there's a related one to what you did, how you just answered this. And the question is related to how you configure Lightbits and OpenShift to maximize for performance, particularly in a multi-node cluster.
Right. So I assume the multi-node is at the OpenShift level. Mm-hmm. Again, from our perspective, to get into this low latency or the high throughput that we provide, the bottleneck most of the time is going to be the network and slash the TCP layer between the OpenShift and Lightbits. If you are running in a, I doubt that you are, but let's say you are running in a completely 1 gig interface environment, you're definitely not going to, very outdated network environment. You're definitely not going to be able to take advantage of what Lightbits can provide. We see most of our customers are running 100 gig NICs or network adapters at the Lightbits level. A lot of them are running it in a redundant manner. So they're bonding 1, 2, even 4 of these at the target level. And then what we see nowadays mostly on-prem is at least 25 gig cards on the OpenShift side. And again, depending on the resiliency level, whether you want to have 2 ports and bond them or not, that's really up to the customers. But these are the key things. From the CSI perspective that connects OpenShift into Lightbits, there's really not a lot of things that you can tune from that perspective. It is more of the applications, how many applications, and the infrastructure between OpenShift and Lightbits.
Great. Thank you for clarifying that. I think you both mentioned CSI drivers in your presentations. The question is how are those accessed for storage solutions like Lightbits?
So CSI, in short, is just the ability to connect externally into some sort of a storage. It has a few functionalities, and Joe mentioned that. You need the ability to use an API to create a PVC, which translates into a volume in a Lightbits, delete. You need the ability to migrate it. You need the ability to monitor it. So these are the attach into a worker node, detach, and then attach into another worker node. All of these things are done by the CSI driver. The communication itself, as I said, NVMe over TCP is a kernel model that is since 4.10 kernel or 4.11, if I'm not mistaken, has been a part of the kernel. So our CSI driver basically makes sure that the NVMe over TCP kernel model exists on the OpenShift worker node, and everything since that point of view is completely regular CSI transactions or interactions. You dynamically create a PVC with your deployment. It will create it on Lightbits. You get to choose, as I mentioned, the number of replicas that you want to use. All sorts of parameters like encryption, not encrypted, compression, no compression. The number of replicas are being decided by the storage class that you are using. So you can have a storage class for 2 replicas, a storage class for 3 replicas, storage class for 2 replicas with a QoS of this limit. And this is really up to you which storage class you're going to use for your deployments, for your pods, for your stateful sets. And that's since that point, it's all automatic.
Can I I'd like to add one more thing, and Sagi knows this actually because he's the one who worked very closely with us on it for inclusion into OpenShift. OpenShift uses the concept of operators, right? So when you want to install these CSI drivers on your host, you're going to go to the operator hub within OpenShift, and we make it pretty easy with our partners like Lightbits to lifecycle and update those CSI drivers. So there's really not much work for the user to do in going and finding CSI drivers, making sure the versions are correct and things like that. They're just going to go and within a few clicks, they're going to have the storage driver, the CSI driver installed and ready to use, and they can create storage classes calling each CSI driver that they have. So for example, if they have, let's say they have NFS-based archival storage, they may have a storage class for that specific storage, right? And then they have the high performance storage for Lightbits, they'll have a storage class like that. And we didn't really get into storage classes as much, but that's a way of differentiating the capabilities in storage, like Sagi said. So we try to make it as easy as possible for customers to utilize the storage that they want with partners that certify and go through a process to get these operators, available to our users. So there's a test process that they go through to ensure that everything works, and they're listed in our software catalog. So that's something we take pretty seriously.
Got it. By the way, I think I put a link to that in the attachments as well, to the catalog, the ecosystem catalog. Well, listen, I don't see any additional questions. There is opportunities if you didn't get a chance to ask a question later this month. I know Red Hat will be at the, we'll have people at the Open Source Summit. I know Sagi, you'll be at the Open Source Summit. There is an opportunity to connect there. If you have a data center modernization initiative or are struggling with storage bottlenecks in OpenShift, don't hesitate to reach out to us for help. I've provided links to our LinkedIn profiles. You can reach out to us there too. If you have any colleagues who are interested in this topic, it lives on demand, on video. That concludes our presentation. Thank you both for your input. And I look forward to further collaboration and more blogs from the both of you in the future.
Thank you so much.
You.
Appreciate it.
Thank you.
Bye.